Quick snapshot of where we've gone and where we're going. It's a little bit out of date, but you can see a lot of states we've completed. For some reason, we wound up picking the northern part of the states that hit in the winter, which wasn't the best. But anyway, we've done a lot of these, so we've got a lot of good feedback, seeing where a lot of states are. So I know you guys work very well with the western states and just your region. But we have worked across the country, so if there's ever questions you have on what people are doing, how they're doing it, always feel free to reach out. We can probably point you to someone that has tackled that or facing the same challenges. All right, so really quickly to kind of introduce broadband and what this is, because sometimes there still is some confusion on what exactly it's going to do and what exactly it's not going to do. So as we know today, users have their LMR radios that are used specifically for land mobile radio and mission-critical voice in particular. And then there's other resources available, sometimes carrying smartphones or cell phones to make voice calls over the commercial networks. And then also, a lot of the commercial applications or services used are done over commercial networks. Not always. I know there's some private networks, but quite a bit are done over existing commercial networks. The problem, as we know, is that anytime there's storms or congestion or just a lack of coverage because that's not where public safety operates, you have all those limitations on the commercial network because they're just not designed for typical public safety operations. And it's a come one, come all, everyone's equal on the network, so there's no prioritization for public safety. So really the goal for this initial build-out of the nationwide network is to make these connections to those same applications mission critical. So that same resiliency, redundancy, reliability that you have on your LMR networks today, to replicate that so you're making, so now all of the services and tools that public safety has are mission critical. Now notice that does not mean that the voice networks will be mission critical just yet, because as we will see and we'll go through, that connection, that service isn't going to be rolled out potentially in the initial build-out. This network will be primarily focused on mission-critical data and making sure you have access to those data applications. Now, eventually, the long-term vision or goal is to get to the point where you could be leveraging both voice and data over this network. So now you've got the ability to access what you need on this existing network, but knowing that you can still continue to use those land mobile radio networks for mission-critical voice. Because we know that there's going to be, there's so much trust invested in those networks and so much investment that it's going to be a long time before public safety is willing to migrate off of those networks and fully trust a new network to perform their service. And if there's any questions, please, by all means, feel free to jump in, raise your hand. So this is just another way that we've put together a graphic to try to capture some of that. So you can see here we've got mission-critical voice being used today. There's some, obviously limited low-speed data that's supported on that as well. The continued use or use today of commercial and unlicensed data. And we're going to introduce this new nationwide public safety broadband network in parallel to these other networks. It's not like it's going to replace any of these networks. It's going to be introduced in parallel. And to get to that long-term vision that people see for this, or really desire to get everyone moved onto a single nationwide network providing voice and data services, there are many, many, many challenges to get there. And there's no time frame for this to get there either. So you can see that this is, before we ever get to that long-term vision, there's many things to be conquered. And that's just to try to reiterate. I know there's some confusion. I think some of it's been limited over the last year or two, but there's still some confusion sometimes on, well, when this network goes up, it's going to support voice, because they liken it to cell phones, but it's not mission critical. What do I do with my LMR radios? So we're just trying to make sure everyone's clear that LMR is not going away. It's a long time before you get to this converged network. There's a lot of challenges that will be faced. So that solution for this network is, there's many goals, many high-level goals for the reason why they wanted to create a nationwide network. To have a next generation advanced network of technology from public safety to provide these high data rates that are being leveraged in the sector for different applications, to use industry standards as much as possible while not sacrificing public safety unique requirements, for a lot of benefits there, for interoperability, You also, with a large, using commercial technology, you get big economies of scale. And then also just being able to leverage, whatever commercial advancements go into the technology from the consumer. Since this technology's long-term evolution, LTE is a technology that is being adopted globally. So there's a lot of investment from the commercial sector going into it. So the challenges we mentioned, one of the huge challenges for this is just getting spectrum. If you're going to build out a nationwide network, you need spectrum. And that was accomplished with the passing of the law. You need funding, and that has been allocated, not necessarily received, but been allocated for the build out of this network. But there's other issues we've talked about, governance, policy, how are you going to do this? This is really a new paradigm for public safety in the states and working and building out some nationwide networks, but still having the autonomy that's necessary within each of the states. All right, so a little background on some of the technology. So long-term evolution is the standard that was chosen for this network. It's considered to be one of the 4G technologies that you'll see advertised in the commercials. It's a standard that they kind of changed the way they approach the development of the standard. So a lot of the previous standards had been built upon earlier standards. And the commercial network, it started out where phone calls or voice calls dominated the use of these networks. Well, they've recognized that today, very few of us are using our phones to actually make phone calls. We're using it to browse that web and check email and text and do a lot more data functions. So when they developed this standard, they really designed it to support data first, with voice kind of as a secondary afterthought. And consequently, that's still being worked. So today, LTE networks on your phone today, you're not making voice calls over the LTE network. When you pick up your LTE-capable phone, you're making a phone call over the legacy networks because it's not currently supported on the major carrier networks today. So if you do make a phone call, it's either on the legacy network or it could be some type of voice over IP application, but it's not over the LTE network inherently. The backbone is an all-IP backbone, so that was a big change from some of the legacy systems that required fixed lines or leased lines or dedicated circuits for connectivity. Huge economies of scale potential because of the adoption of this technology globally. Mobility, interoperability, all those things for roaming from network to network or connecting different networks are all built into the standard. Flexible channel bandwidths, which are important as spectrum could potentially be allocated, or more spectrum could be allocated that this technology supports it. High data rates I mentioned. Security, authentication, priority and queue, quality of service, those are all really critical aspects for the build-out of a public safety network, and those are all built into the standard. It's just a matter of how they get implemented and rolled out in the deployment of a network. And then there's some new antenna techniques that really kind of help improve the performance of the system for trying to overcome some of those shortcomings of a low-power, small form factor devices. So a little bit on the basic building blocks. As if you haven't already heard, there will be some new terminology that you'll hear with respect to this system and this technology. This is a chart that actually FirstNet had put together and used to kind of inform some users in previous meetings. So they kind of broke it into 4 different categories. So you start with the core, which it's really the evolved packet core, or EPC. That it usually just gets referred to as the core. The core, you can kind of compare it to a trunk system, LMR system. It's the key, databases, servers, infrastructure piece of the network. And so it has all of the applications, the provisioning, the user management. It's really the, kind of controls the network. And those can be very high capacity things where, for example, the big carriers may only have 5, 6 of those supporting their whole nationwide network. So it's not like what we're more used to with some trunk systems where maybe you've got several cores to support a region or statewide system. These can support big wide area systems. It also means that they've got, with the capacity that they have, they can support, there's a lot of fallback capability where if one goes down, they can kind of recover for the other. In an important building block in this that's much more important, I think, than previous networks is just the transport layer or the backhaul layer. This network requires a significant amount of bandwidth to deliver those high-end data rates to the end user. That requires a lot of aggregation and backhaul. So some existing sites or networks today that support existing voice networks may not necessarily support this type of network because the backhaul requirements are so much more. So that's an important aspect of the network. And then you have the radio access network, or the RAN. So that is the compilation of all the base stations, basically, that are built out, all the tower sites for the network. And that connects through the transport into the core. And the important distinction between the RAN and the core is that when you start working with FirstNet to build out this network, FirstNet's responsibility ultimately is the core. No matter what, they will be building out the core that every state RAN connects into to provide this nationwide network. The RAN will be one of the primary responsibilities in working with FirstNet that the states have to give a lot of input on where do you want that RAN, what will that build out look like, because that's what drives coverage. So that's what we'll talk a lot more about today. So that's the important distinction between the RAN and the core. And then finally, the kind of the last building block is the device side, the end user side. Subscriber units or portable mobile radios. In this terminology, a lot of times it might refer to as UE or devices, user equipment. So different terminology. So with LTE, you'll hear core, RAN, and UE or devices, equivalent to what you're familiar with on the LMR side. So this is the kind of layout of the spectrum. So similar to LMR and VHF and UHF and 700, 800, there's similarities as well with the commercial environment. So they call their spectrum grouping band classes or bands. So public safety has dedicated spectrum in what's called band 14, you can see here. So Verizon's band 13, AT&T's band 17. A lot of the commercial carriers have spectrum outside 700 megahertz. This is just kind of a snapshot of 700 megahertz because this is where the public safety spectrum resides. So early on when the spectrum was allocated and they were looking at different ways to build out this network, they had kind of allocated some spectrum right here for public safety in the blue. And then they had this D block that they were going to do, that public-private partnership. And that failed to go through. The option wasn't met. And they kind of were stuck trying to figure out, well, what do we do with the spectrum now to try to ultimately achieve this goal of building out a public safety broadband network? So when the legislation was passed, that we'll talk a little bit about, it allocated that spectrum to public safety. So now band 14 is dedicated, allocated for the build-out of this broadband network. You can see it's 20 megahertz total, 10 megahertz on the uplink, and 10 megahertz on the downlink. So 20 megahertz total. So sometimes you'll hear it 10 by 10 or 20 megahertz or 10 megahertz, but it's broken down. It's different than the 700 megahertz allocation for LMR. So any of the LMR systems that might be using 700 megahertz channels for their voice networks, those are a different chunk of spectrum, and that's all allocated to public safety. You'll see too that the amount of spectrum allocated is actually pretty comparable to, like, for example, what Verizon has, just adjacent. So they're building out their nationwide network for LTE on an 11 by 11 piece of spectrum. They have other spectrum in different bands where some of their legacy networks operate. This is specific to their LTE network. And they're looking to acquire more spectrum. So public safety does have quite a bit of spectrum compared to the commercial carriers for the build-out of this network. And these band classes are important because that's what separates your phone from being able to operate on different networks. So, for example, if you just take your Verizon phone, just because it does LTE, operates at 700 megahertz, doesn't mean it'll be able to operate necessarily on the public safety network, because it's going to be dedicated to operate on band 13 and maybe a couple other bands in different parts of the frequency band. So as phones come out, they may very likely support multiple of these band classes. They do today, but there might be ones that will support the public safety band. But it's not just kind of a come one, come all. If you do LTE, you do 700 megahertz, you can operate in the public safety band. So we talked a little bit about voice and the fact that mission-critical voice is desired to ultimately run on this network, but will be quite a while. And it quickly became apparent that there wasn't really a recognized definition of what it meant for public safety voice, mission critical voice. So NIPSIC, the National Public Safety Telecommunications Council, made a group, I think Michael, you may have participated on that group, developed a white paper that helped define what is mission critical voice. What does that mean? And they came up with basically these 7 kind of high level functions, and those are, and they're defined, in more detail in this paper, but those were good areas of what really defined mission critical voice. And some of the key ones that are really unique are definitely push-to-talk voice, so you don't typically have that on cellular networks today. There can be some, the Nextel network that did specialize in it, but in most networks are not doing push-to-talk voice. Direct mode or talk around is a huge one. Today in commercial networks, your phones always have to go through the infrastructure, talking to base stations. There's no device-to-device communications over the LTE network. You can do it over Wi-Fi or other technologies, but not over LTE. So that's a big one that is required in the LMR networks and the way public safety user radios today that's not supported by this technology. Emergency alerting is also a big one, being able to make emergency calls or notify people of an emergency. So this was a really good definition to help if this network is eventually going to support public safety and their mission critical voice requirements, it needs to meet these things. You can download it at the website here, and this definition is being helped to drive the standards development now and the standards bodies to start addressing some of these needs. So for example, just recently, push-to-talk was accepted in the standards committee, so that's now being worked into the standards for LTE, and as well as they call it proximity services. So basically, the ability to support this direct talk around mode. So that's also being worked in the standards. So it's a really good thing. This is, it's different because this is a global standard and it's primarily driven by industry. Now, public safety having a role in this, it's a little bit different than they've had in the past when they had complete control over, for example, like the Project 25 standards, P25, where they drove the development because public safety was the primary user of those standards. So, trying to break down voice a little bit and clarifying why you might hear voices can be done over LTE or no, it can't. So today, there's no reason that because it's a data network that you can't run voice over IP. So Skype or Google Talk or any of those type of voice over IP applications can absolutely be done over the network because they just look like to the network another data application. The commercial carriers are just carrying out this a standard for LTE to support voice, so they can start to migrate their users onto the LTE network and support voice and get people off some of their old legacy networks and recover some of that spectrum and some of that backhaul infrastructure. So the standard that's going to support voice, so you start making a voice call over your phone, is called VoLTE, or Voice over LTE. And that, it looks like a lot of the carriers are targeting releasing that this year, sometime this calendar year. There are some push-to-talk solutions that exist today over LTE. There's nothing that's standardized yet, and I think they're kind of coined non-mission critical because they don't meet some of those requirements identified by the NIPSIC requirement, primarily the latency. Low latency is required for public safety operations, and some of these push-to-talk solutions don't meet those latency requirements. So there is no push-to-talk requirement that supports mission-critical operations, nor is there a direct mode on this network, like I've said. And so that's why when you start hearing voice and what voice can be implemented over LTE, it's kind of important to know, well, what are you talking about? Are you talking push-to-talk, non-push-to-talk, low latency, non-low latency, the voice over IP? What type of voice you're talking about? Because if you want to support public safety, you have to be down here, and what's being worked on right now is up here. Any questions so far? All right. So I mentioned the standards body developing LTE. This is it's a global standards body. Standards group has worked all the way back to the GSM days, so it's a proven standards body. They've got a roadmap for the future, so they've already started in on LTE Advanced, even though the networks today are deploying LTE. So they're continuing to work at developing these standards, which is great for LTE because it means that these networks are being built, especially the network, that there's a roadmap for the future for this technology, and that it's not going to be abandoned in lieu of something else. All the carriers today are deploying this technology, and focused on solely this technology. It's the first time all the major carriers in the country have deployed the same technology with their networks. So that's a great thing for the future of this technology. I mentioned a little bit the standards body that's developing this. So it is a commercial entity. However, FirstNet has actually worked with a group out of Boulder, the Public Safety Communications Research Group, and have tasked them to help participate in these standard development meetings to kind of be the voice for public safety in FirstNet. So they've done a great job of partnering not only with a group within that organization, but also kind of there's been a lot of momentum built up globally, building a strong voice for public safety, which has helped really prioritize some of those public safety requirements in the development of these standards. So as these standards evolve, it's anticipated that they'll be able to support some of those public safety unique requirements that aren't supported on those networks today, like push-to-talk, like direct mode. So that's a big step, because when this work first started, there was a difficulty in getting traction within that group because they just weren't prioritized. Public safety requirements weren't prioritized in that group, and they are today. So that's a big change. All right. Any questions kind of on the technology background? You guys are pros.